In this video, we will look at water-sensitive design components. These systems are becoming more popular as the effects of pollution and development affect natural systems, and that this becomes more of a concern to the wider community. Systems designed using water-sensitive design principles use components that imitate natural processes. For example, an important part of a natural system's treatment of stormwater is to allow it to soak into the ground, as here. Traditional systems lessen the amount of infiltrated water and maximize the amount of surface water. Systems designed to water-sensitive design principles allow infiltration of the rainwater into the ground, as shown in this diagram. This has the advantage of maintaining natural groundwater flows to natural local water bodies, preventing some parts of the local water bodies from drying up, but also preventing other parts from experiencing higher flows. Water-sensitive design systems also allow for rainwater to be retained within the community for longer periods of time, rather than discharging into pipes which quickly move the water into local water bodies. This has the advantage of maintaining stream and river flows close to their natural levels. In addition, the water-sensitive design allows treatment of runoff before it enters local water bodies. This has the advantage of removing some of the pollutants produced in the community, which are especially prevalent on roads. So the water going into the water body receives some treatment and is therefore cleaner, reducing pollution of that water body. So the removal mechanisms that can happen in a water-sensitive system, as I said, are very similar to the ones that happen naturally. So the first one is screening, which involves the removal of gross particles such as litter or suspended solids. They get caught up in the grass or vegetation as the runoff moves through it. So that's surface water. Infiltration is where the runoff soaks into the ground, so preventing it from flowing directly to the water bodies. Once it's in the ground, filtration occurs when the infiltrated water passes through the filter media or through the soil. The solids are getting trapped in the voids between the soil or filter particles. Adsorption occurs when the infiltrated water is moving through the soil as well. Some soil particles have static charges that cause fine pollutants to adhere to them, so removing the pollutant from the water. Sedimentation occurs in bodies of water such as wetlands or ponds. This is where the solids suspended in the water tend to sink to the bottom. The water at the top of the water column is therefore clean and is decanted and discharged to the water body, leaving the solids on the bottom of the pond or wetland. Decomposition is where microorganisms within the soil or on the surface of the vegetation cause organic compounds within the water to decompose into more stable elements that do not have as significant adverse effects on the water as the organic compounds that they are decomposed from. Let's look at some of the systems. So vegetated swales are channels with vegetation planted in them. The runoff flows along the channel to a disposal point. During its travel, it moves through the vegetation, which causes screening of the gross pollutants within the water. Some of the water also infiltrates into the ground, leaving less surface water entering the drainage system, and also allowing the infiltrated water to be treated as it moves through the ground. This photo shows a vegetated swale with a manhole in the middle. The manhole is raised about 200 mils above the invert level of the swale. This means that in heavy rainfall events, the swale acts as a shallow pond. If the pond of water gets above the level of the manhole, then it will flow into the stormwater system, so preventing flooding of the surrounding area. However, after the storm, the ponded water is free to infiltrate back into the ground. So once again, they provide transportation and buffering of storm flows, as well as a significant amount of treatment. Road runoff may also flow to a rain garden for retention and treatment before discharge to the stormwater system or infiltration into the ground. In a rain garden, screening of gross solids is carried out by the vegetation. The runoff then infiltrates into the soil where filtration and absorption processes occur. Rain gardens also allow water to pond during high rainfall events. After the event, the ponded water soaks into the rain garden. Rain gardens may also either drain down to an under drain system under the surface that connects to the stormwater system, or where the soil is quite permeable, they may allow the water to infiltrate into the natural soil and into the groundwater system. So if you've got a highly permeable soil, then a rain garden can be your disposal mechanism. If you've got an impermeable soil like a clay, then you probably have to put a stormwater system in there because the ground infiltration cannot match the amount of rainfall. So these photos show more constructed type rain gardens. The rain garden on the left shows a curb with cutouts. So there are the cutouts there, which allow the rain runoff from the road to enter the rain garden. In this case, the rain garden overflows to a rocky area in the foreground, where it eventually enters the stormwater system via the manhole shown. The system is in the north shore of Auckland, which has clay soils, so it's assumed that there's an underdrain system under these rain gardens. So a lot of during normal weather, most of the water will infiltrate down to the underdrain system and then drain into the stormwater system. However, in high storm events, when this all becomes flooded, it will overflow and go into the manhole. This photo on the right shows a precast concrete box which is used for rain gardens. It shows the underdrain, so you can see that there's grating here to prevent the filter media from dropping down into the underdrain system. There are pipes there, perforated pipes, and they drain to this main pipe here. This is raised above the ground to allow you to clean the whole underdrain system from the surface. These types of rain gardens are normally filled with topsoil and bark mix. This provides the permeability required for infiltration, and the soil and bark particles also enable the absorption of fine pollutants from the water onto the surface of the soil or bark particles. Filters are mechanical devices that typically occupy a smaller footprint than the more natural devices such as rain gardens and swales. The water flows into the filter's first chamber where sedimentation occurs. The decanted water flows over the top of the middle weir into the second chamber, which consists of a layer of fine sand overlaying a layer of coarse drainage material. The water is filtered as it moves through the sand layer. The treated stormwater is then discharged into the stormwater system from the outlet pipe. Wetlands are shallow basins planted with wetland plants. It usually takes a number of days for the water to make its way from the inlet of the wetland to the outlet, usually on the other side. In this time, the suspended solids tend to sink to the bottom, and the clean top water is decanted off at the outlet. In addition, the wetland plants screen gross pollutants as the stormwater moves through them. The wetlands also provide a suitable environment for microorganism communities to thrive, which provides additional biological treatment of the stormwater as it moves through the wetland. Road runoff may also flow into ponds. These are usually deeper basins than wetlands and so provide more storage for the same footprint. The ponds can provide a good buffer between the road runoff and natural systems, with the outlet from the pond being sized to control flows into the natural systems. Ponds may be wet or dry. Wet ponds are full of water all the time, whereas dry ponds are only filled during storm events and drain back to a dry state after the event is completed. Both of these types of ponds provide buffering between the stormwater flows and the natural water system. Ponds can also provide sedimentation treatment and some infiltration in impermeable soils. Water-sensitive design may also include surface features that allow infiltration into the ground. This can be used to enable infiltration into permeable soils or can provide buffering of stormwater flows. One way of doing this is to make trafficable surfaces permeable using permeable paving or block pavements. Block pavements allow water to seep through into the underlying drainage layer through the cracks between each paving block. The paving blocks themselves may also be slightly permeable. Another alternative is to use open graded porous asphalt or OGPA to provide an asphaltic concrete layer that is permeable. Both of these systems have to be laid on a drainage layer that is not as strong as a typical base course. This means that these systems are normally used in low loading areas such as parking lots or driveways. They can also be combined with underground pits or trenches which store larger volumes of water. This allows storm flows to be stored until they can be fed into the stormwater system after the storm flows have abated.